Look at some problems. You randomly select one card from a 52 card deck. Find the probability of selecting the 3 of spades or the 10 of clubs. It's an or problem. It will be addition. We have to know, are these mutually exclusive? Yes, they are. The 3 of spades has nothing to do with the 10 of clubs. So how many 3 of spades are there? There's one card that's the 3 of spades. How many 10 of clubs are there? There is one card that is the 10 of clubs. We have a common denominator. Keep the common denominator and add. 1 plus 1 is 2. Reduce that to 1 over 26. A single die is rolled. Find the probability of rolling an odd number or a number less than 4. Let's write out our sample space. The probability of rolling an odd number, 1, 3, 5. So I have 3 out of 6 for the odds. The numbers less than 4 are all of these, which would be 3 out of 6. But notice in my circled red group, I have 2 dotted blues, meaning I've already counted those. That's my overlap. I need to subtract 2 out of 6. So keep the denominator. 3 plus 3 is 6, minus 2 is 4, which reduces to 2/3. Now there's another way to do this without the formula, and it is to have the sample space in front of you and just circle up what works. Odd number, 1, 3, 5. Not writing anything down yet. Then I want to find or number less than 4. That's less than 4, but I've already counted it. That's less than 4, so I need it. That one's less than 4. I've already counted it. Look at what you got circled up. You've got 4 elements circled up, which reduces to 2/3. I think this is a decent method if you don't have too many of them to go through and count individually, but your choice. You are dealt one card from a 52 card deck. Find the probability that you are dealt a 2 or a black card. You have to ask yourself, is there an overlap between here? Is there a 2 that's also a black card? And the answer is yes. So this is where we have to use the formula of P of A plus P of B minus P of A and B. So how many 2s are in the deck of cards? 4 out of 52. How many black cards are there? There are 26 out of 52. Your black cards, remember, are all your spades and all your clubs. Take away any overlap, meaning how many black 2s are there? There are 2 black 2s. There is the 2 of spades, there is the 2 of clubs. Add this up, will give us 28 over 52, which reduces by 4 to give me 7 over 13. A single die is rolled. Find the odds in favor of rolling a number greater than 1. Okay, so here's my sample space. How many of those numbers are greater than 1? All of those. So odds in favor, that's my win over my lose. How many ways can I win? I can win 5 ways. How many ways can I lose? Just that one right there. So it could be the fraction 5 over 1 or 5:1. Back to cards. One card is randomly selected from a deck of cards. Find the odds against drawing a black 3. Well, against is lose over win. How many black 3s are there? There are 2. You're only going to win if you draw a black 3. There are 2 of those. There's 2 ways to win, and I put it on the bottom because that's what this formula tells me to do. If there's 2 ways to win, that must mean there are 50 ways to lose because there's a total of 52 cards, and that will reduce to 25 over 1, or in colon form, 25:1. You are given odds of 2 to 3 in favor, odds in favor of winning a bet. So you're looking at this, which leads to our probability being, keep the numerator, add those 2 things up. Looking at a table now, it says the table shows the educational attainment of the population of Mars, ages 25 and over, expressed in millions. Find the probability that a randomly selected Martian, age 25 and over, has completed 4 years of high school only, or is a male. So 4 years of high school only is right here. All of this is my 4 years of high school only. Or is a male. My male is all of this. Now, when you got it in chart form, it's clear you have an overlap. You've got something counted twice. You've got something counted in the red and something counted in the blue. So now I go back and do the arithmetic on this. We're looking for 4 years of high school only. Well, the totals given to me is 57 out of a total number of Martians of 172. Add your total number of males surveyed is 85 out of 172. But you must subtract away the overlap. There are 31 students who have been counted as males and as taking only 4 years of high school. So we must subtract the 31 over 172, which will give me 111 over 172, which does not reduce. And by the way, this is in millions, so technically it is really 57 million over 172 million, etc. But all those millions are going to cancel out, and that's why I can just use the numbers that are in the chart. One more chart problem. Same thing, we've got these Martians 25 and over expressed in millions. Find the probability that a randomly selected Martian age 25 and over has not completed 4 years or more of college. Well, my students that have completed 4 or more is right here. These are the only people surveyed that have completed 4 or more. They want to know the ones that have not. So what I would need to do is add up my total here, 26 plus 52 plus 45. Of course, all of these over 159, which is 123 over 159. And believe it or not, these reduce by 3. And how do I know it reduces by 3? There's an old rule from your grade school days. If the sum of the digits is divisible by 3, then the number is divisible by 3. 3 plus 2 plus 1 is 6. 6 is divisible by 3, so I know 123 is divisible by 3. Same thing down here. 9 plus 5 is 14, plus 1 is 15. 15 is divisible by 3, therefore 159 is divisible by 3. So you can use your calculator at this point to divide top and bottom by 3, and we get 41 over 53. Of course, if you have a scientific calculator, it will do these reducings for you. There's another way to do this problem, and it uses the definition that we learned in the beginning of the 11.6 video, and that is using this word not. So I want to know what the probability that these Martians age 25 and over have not completed 4 years. Well, we know that there are 36 out of 159 who have completed college. Well, if there's 36 who have, how many are there who have not? Well, this was this idea that we need to subtract that from 1. So 1 minus 36 over 159. Of course, 1 is the same as 159 over 159. Minus 36 over 159 gives me that 123 over 159, and then you can reduce like we did over here in the red. So you can use the formula for not, or you can just add these up individually, whatever works for you. Last problem, we've got another chart here. If one person is randomly selected from the population represented in this bar graph, find the odds in favor and the odds against. Well, we'll just get the odds in favor first. So the odds in favor would be like this winning over losing idea. So we're going to win if a person is a woman in the Marines. Think about it that way. We win if we choose a woman in the Marines. Well, there's only 10 women in the Marines. This is the Marines section, and there's only 10 women. So there's 10 women. We need to find out how many are not women in the Marines, meaning add all these other things up. So that's 300 plus 70, that's all the Air Force people, plus 420 plus 80, that's all the Army people, plus 170, that's the men in the Marines, plus all the Navy personnel, which is 320 plus 60. And if I add all of that up, I'm going to get 1,420 people. So if we were drawing out of a hat and I only won if I pulled a woman's name in the Marines, there's 10 ways to win versus 1,420 ways to lose. This reduces to 1 to 142. Now that's the odds in favor. The odds against, all I have to do is get the reciprocal of that, flip it upside down, is 142 to 1.